Okay, students, so now what we're going to do is I'm going to show you how to do the ELISA concentration calculations. This is the paper that is green on your table. So you should be doing this assignment if you are the materials manager. This is a green paper, green. Okay, so what you're going to do is you're going to use this data here. You're going to answer the questions below. So here what we see are data. This is data from the experiment that we did on ELISA. So here we have the concentration of antigen and the brightness. So what we want to look at here is to look at how the data is changing. So in this data, so the question here is asking us, how does the brightness change as the concentration changes? If you don't know what this question is saying, please translate the question here, write it in your home language. You can write in English, or you can write in Spanish, Chinese, or Arabic. So I want you to look at how does the brightness change as the concentration changes? So here we're seeing, so it says while the concentration, let's see, so the concentration from 125 to 250, this is increasing. So while the concentration increases, the brightness, how does the brightness change? Does the brightness increase or decrease? You're going to pick which one of these two answers are going to help you answer the question. Same here, you're going to use ML. You can translate the question here into your home language. So what you're going to do here is you're going to use this information from here. So we're going to use this information to help us estimate the patient samples. So here we have the standards that we use, but let's look at the patient sample. So here for Sue, we had a brightness of 37.64. So let's see, 37.64 is between 34.48 and 40.98. So it's between these two values. So and that concentration is between 500 and 1,000. So what I will say is that Sue's concentration of antigen is between 500 and 1,000. You're going to do the same thing for Jill, Wanda, and Maria. Tell me if it's less than 125, 125 to 250, 250 to 500, 500 to 1,000, or more than 1,000 for each of the patients. Then you're going to go here, you're going to get a graph that's called the concentration data linear equation graph. So you can find this on Google Classroom as well, but you can get this paper from your teacher. The paper looks something like this. So you're going to use this data to help you answer the questions. So the first question here says, okay, so I'm going to take a screenshot of it so you can see it on your side. So it says you're going to use this data to help you answer the question. So it says here that Sue has a brightness of 37.64. So I'm going to go here to my graph and I'm going to find approximately where 37.64 is. Well, it's kind of hard to tell, but this is 30 and this is 40. So this here would be 35. So what I'm going to say, so 35 is like around here. So I'm going to say that 37 is like something like right there. Right, we're looking at brightness, brightness and brightness. So at 35, I'm going to say that this is about approximately 37.64. Again, this is just an estimate, 37.64. I'm going to draw a line from here all the way to the line itself. Then from there, go all the way down and onto the x-axis and see where it falls. So this here is 750. This here is 1,000. So that means that the number between these two numbers here is about, let's see, 875. This is 875 right here. So I would say that this here is maybe approximately like 825. That's an approximate estimate. Again, I don't need you to have an exact answer. I want you to estimate. So that means that the concentration is approximately 825. And the units are micrograms per milliliter. I want you to do the same for Jill, for Wanda, and for Maria. Then on this part, it's asking you for the equation of the line. So what is the equation of the line? So here we have what the equation is. It says y is equal to 0.0149 times x plus 23.8. So here you're going to write that equation. So y is equal to 0.0149 times x plus 23.8. You want to look at what the variable on the x-axis is. Again, the x-axis is this one. This is the x-axis. This is the y-axis. That's going to help you answer number 4 and 5. And then it's going to ask you, how do you calculate the brightness of the sample? So remember, since the brightness is this is your y-axis, that means that this y here is brightness. On the x-axis, we have concentration, so your x variable is concentration. So you're going to fill in that information here. You're going to, and then again, this is the number that's in front of here. So this is 0.0149. This here is 23.8. So you can write in brightness or concentration for the y. This is for the y-axis, and this is for the x-axis. Then you're going to just rewrite this exact same thing, but now with words. So this equation here is the same as saying, right, brightness or concentration. Again, you're going to pick which one is on the y-axis, is equal to the number multiplied by the brightness or concentration plus the number 23.8, right? So these numbers are going to be the same. And again, you can write in your home language if you want to. So now we want to see if this equation works. So let's use it unknown concentration. So we know that this is our equation here. Y is equal to 0.0149 times x plus 23.8. So we're going to use it here and see if it works. So we want to calculate for the concentration of antigen. So let's see, we're starting with 125. So again, y is equal, so first we're going to multiply by this x. So we know that our concentration here, right, the concentration is 125. So I'm going to plug in 125 into this equation. So if the equation again is 0.0149 times x plus 23.8, I'm going to plug in these concentration values into this equation. So first we get 0.0149 times 125, right? Because 125 is a concentration, plus 23.8. Then you're going to put this into your calculator and find what the answer is. You're going to do the same exact process for each of these. And tell me if you think that this more or less estimates the brightness of the sample. So you're going to check if these numbers right here are similar to what you have here. Are they the same? Are they very different? You decide, yes or no. For this last part, what you're going to do is, again, just look at what each variable represents. Again, we know, for example, so this is the y is going to be whatever's on the y-axis. So which variable is on the y-axis? What's on the x-axis? What is this m? So what is the thing being multiplied by x? In this case, right, the m is the thing that is multiplied by x. So in this case, this is the m here. And this is b. So you're going to write the numbers. These are going to be numbers. And these are going to be either concentration or brightness. Okay, you're going to rearrange this equation after. So this equation is being changed. So this is another equation. So x is equal to y minus b divided by m. So again, so x, what did we say x was? You're going to use whatever x is here. So it's going to be either concentration or brightness. Y is also another thing. B is a number, right? It's a number. So you're going to write the number there. And m is also a number. So you're going to write those numbers. You're going to write that information into this line. And again, translate it if you need to. Then you're going to use this equation to calculate the concentration of each sample. So we know that our y is what, right? Our y in this case is our brightness. Our x is concentration. Our m is 0.0149. And our b is 23.8. So I'm going to calculate the concentration for each of these samples. So again, I'm going to follow this equation. So this is the brightness, right? So the brightness is our y minus b. Well, b is this guy, 23.8, divided by m. M here is this. And then you're going to tell me what the answer is. You're going to calculate. Make sure that you use parentheses first. And please do the same for Jill, Wanda, and Maria.